green marble. Then the probability I pull out a green right now is 2 green out of 5 marble, right? 2 are green out of the total. But if I put it back in again, then it always stays 2 out of 5 for green. But if I don't, if I do it without replacing it, without putting it back in, then now I've got, of these marbles I started with, the second time, if I, let's say, got a green, right? But then I didn't put it back, now my probability of green is different, right? Now I only have 1 green left out of 4, right? So it's changing depending on what I get. And if I got pink first, then it would be different to get another pink versus a green, etc. Okay? So if you take your union formula and you modify it for mutually exclusive and independent, you get a new formula. So that's, totally possible in the exam that they say mutually exclusive or disjoint. And maybe they say, what is the union? And so if you look at your union formula, this you have to memorize, right? Probability of E union F is probably the first, which is E, plus probability of second, which is F, minus first and second, E and F. But if we know that we have mutually exclusive, then we know that E and F has probability of 0. So if we take that into consideration, then the last term's gone, and our formula just becomes this. So you can modify that basic formula for mutually exclusive. You can also modify it for independent. So if, for example, we had that the probability of E was 1/2, and the probability of F was 0.2, then there'd be 0.3 left out of the total of 1. And the probability of being in E or F or both would just be this plus this, right? Because there is no E and F to subtract. So we would literally just add them and get 0.7. Okay. Now for independent, that's different. Remember, don't ever write for independent that E and F is 0. For independent, we know that the probability of E and F is E times F. So if we take the formula and we kind of modify that, we take this last term and change it to times, then this is our formula. Okay, now you can only do this. This is only if E and F are independent. So don't think you can just randomly change the and into multiply whenever you want, because that's not going to work out well for you, right? So only if they're independent can we turn that last term of E and F into a product, okay? Okay, so probability is full of formulas, and I did put them all in that printable equation sheet for you, along with a whole bunch of other stuff to work on. But something else that you know, if events are independent, we know that they don't affect each other, right? So the probability of A and the probability of A given B happens are just the same, because if A and B don't affect each other, then the probability of A given B is just whatever A was originally. Same thing with A given not B. If they're independent, they don't affect each other. So also, we could say the probability of B given A. Well, if B is not affected by A, if they're independent, then B given A would just be B. And guess what? Same with B given A doesn't happen. If B is not affected by A, then B given A doesn't happen would still just be B as well. Okay, so that's for independent events. Okay, so when A and B are independent, then A given B, A given not B is just A. Okay, so sometimes they will ask about some of these commutative, associative, distributive laws. So do memorize them. I would say that, these two are probably the most important. So if you take a bracket and you want to complement it, so if you take E union F and you want to complement it, what we do is we complement both of the sets, E and F, and then we switch the sign. So if you want to complement a bracket, complement both of them, and then switch the sign. So a lot of people look at this and go, okay, E or F or both. That's the union, E or F or both. And they're good, and then they go complement and they go, what? Where's that? But when you do this, everybody tends to know that that's the outside of a Venn, right? That is, if we've got our E and our F, then not E and not F is whatever is out here, right? It's not in either circle, in other words. Okay? The other one, right here, same thing. We can complement both sets and switch the sign. This one, so this is not in E and not in F. And this is not in E or not in F. So be careful that you don't mix them up, right? The or versus the and, because that's a big problem, right? If you write the or, it's supposed to be an and or vice versa, you're going to get a lot of stuff wrong. So not in E or not in F. So what would that look like? So let's shade it. Not in E or not in F. So let's do this in orange. So not in E. Well, not E would be to cover up E and shade everywhere else. There's not in E. Okay, so not in E. Or not in F. So cover up F and shade everywhere else. So not in E, I've got to shade that too, right? For not in E. And then for not in F, if I cover up F, now that has to be shaded. So everything's shaded except for the middle in this one, okay? So, E and F is the middle, so E and F complemented is everything except E and F. Okay, so just make sure that you write out these until you kind of know the formulas. I know there's a lot. I wish you got like a formula sheet. Okay, so let's do some probability. So if you flip a fair coin 6 times, what's the probability that you get at least one tail? So 6 flips, at least one tail. Anytime you want the probability of at least one of anything, you probably don't want to do it directly because it's going to be trickier. Like we could have 1 tail, 2 tails, 3 tails, up to 5 tails, 6 tails, right? That's a lot of cases. And can you imagine drawing a tree for 6 coins? That'd be a royal pain. It would take you forever. So always when you see at least one, think about what's the missing case. The missing case for at least one would just be no tails. So that's the formula that you want to memorize and apply anytime you see at least one. 1 minus the probability of none. So no tails will always just be one case, right? Because no tails is just head, 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 head 6 times, right? So that's one case out of what? Well, we said if we flip, 6 flips of the coin, then we have 2 to the 6 or 64 possible outcomes, right? Remember the 2 comes from heads or tails. So really we just have one case out of 64 that we can't get. Everything else, all the other 63 out of 64, we can get, okay? So at least one tail, 1 minus the probability of no tails. Okay, Peter rolls a die twice. Okay, so what is the probability of getting a sum of 7? Okay, so if they ask you a dice question, you won't have this, but you can take a look at this now and think about the outcomes. And remembering that there's always going to be 36 for rolling a die twice. 36 possibilities. So then what you want to write down is what are all the ways to get a sum of 7? Well, just think about the die, right? We could get a 1 and a 6. That would add up to 7. So would a 6 and a 1, the other order. A 2 and a 5 and a 2. A 3 and a 4 and a 3. So this is 6 cases out of 36. And so we can reduce that to 1/6. Decimal is technically that, which of course you wouldn't get unless you had a calculator. Okay, so these are, sum of 7 is actually the most of everything. You know, sum of 12 is only one case. Sum of 2 is only one case. Sum of 11 is 6, 5 or 5, 6. 2 cases out of 36. Okay, etc. Okay. So for this one's, you know, a little bit tricky. It's a lot of work, I think, I would say. And so it says if probability of A is 0.1 and probability of A and B is 0.05, okay, and then the union, probability A union B is 0.35, then find the probability of B. Okay, find the probability of B. Well, anytime I see this, whether it's given or I'm finding it, I would write down the union formula. So do you remember it? Something plus something minus something. So it's probability the first one listed is A, plus probably the second one, which is B, minus first and second, A and B. Okay. So we can fill this in on the left, 0.35. Probability of A is 0.10. We don't know B. Minus A and B, 0.05. So we can just solve 0.1 minus 0.05, so that's 0.05 plus B. So you can move things across, or you can just think, you know, 0.35 minus 0.05 and just do it in your head like that. So it's got to be 0.30, right? So that part, not so bad. Easy, you just have to know the formula. But part B is a little bit trickier. So A union not B. A union not B. So that means it's in A or not in B. And of course, for a union, it's always or both. So in A or not in B or both. Okay, so if you look at your basic union formula up here, we can modify it, right? So it's generally probably the first is A plus the second is B minus first and second. But now our A is still first, so we can say probably the first is A, but our second is now plus B complement, right? So union is probably the first, probably of A, plus probably the second, B complement, minus first and second, A and B complement. Okay? So let's think about what we have on a Venn diagram from what we got in our first part. We had that A and B was 0.05. That's the first place to label. So that's 0.05, right? That's and. And then we knew that the probability of A was 0.1. So think about it. If the probability of the whole circle of A here is supposed to be 0.1, right? Then what is the sort of moon-shaped right here? Well, that's got to be 0.1 minus 0.05, right? Because there's 0.05 in the middle, and the whole circle of A includes that and that. So that's 0.05 as well. Now, what about B? Well, we just found out that B was 0.30. So the whole circle of B is 0.30. So go ahead and fill in, you know, what would this moon shaped here be? Should we take our 0.30 and take away the middle? And that would mean this sort of moon shaped here would be 0.25. And then the last number, remember you've always got 4 numbers. If you have 2, you know, an A and a B, 2 sets. So we've got 1, 2, 3 here. We need the outside number. All right, go ahead and write what would be on the outside here. So out here, that's got to be everything that we're missing to make it add up to 1. So 1 minus 0.05 minus 0.05 minus 0.25. So that's 25, 30, 35. So that's 0.65 out here. Okay, so then you just need to use your formula. So you need the probability of A. Well, A we had up in the question, and you can also just look at your picture. A is 0.1, right? But it was given in the question. So that's 0.1. B complement, there's 2 ways you can do it. We found B, 0.3, so that would mean the probability of not in B would always be just 1 minus what is in B. So, in other words, 0.7. That's one way, right? We can use that formula. The other way to find not in B is because we drew a picture, so we can find this last term easily. Well, then we can just say not in B would be to cover up B and add everything else. And everything else would be the outside and this spot here. And that would be 65 plus 5, so that'd be 0.70, right? But we can also just say 1 minus what's in B. Either way, 0.7. And this one we can get from our picture in A and not in B. So what's going to be in A and not in B here? In A and not in B. So that's this kind of moon shaped here, right? So if we do this, we've got 0.1, so 0.7 is 0.8, 0.8 minus 0.05. So think money, 70 cents plus 10 cents is 80 cents, 80 cents minus 5 cents is 75 cents. Okay? Now, please beware that the question asked us for probability of A union not B, whereas this is A and not B. So if you accidentally gave the answer 0.05 for this, it's going to be there for sure. And it's probably going to be the most common wrong answer. So just beware, right? Union or means in A or not B or both of those. But A and not B is just this one little spot there. Okay. All right, any questions? Okay, you guys are doing awesome. So flip over if you're ready. Okay. The 0.65 right here. This represents what's not in A and not in B. So this is not in either of them. Yeah. So if they were to ask probability of not A and not B, it would look like this. Like that. Okay. Okay, so if you don't play cards, you're welcome. Here's a, kind of a layout of cards for you. So there's 13 types of cards. So these are called aces, A's, and then 2 to 10 is obvious. J's are called jacks, Q's are called queens, K's are called kings. These 3 are called face cards. And in real life, these are black cards and these are red if you have just a standard deck. So some people call these the denomination of the cards. I just say 13 types. And then here we do have 4 suits. And the total is 52 cards in the deck. So, for example, the 4 suits, there's 13 clubs, 13 spades, 13 hearts, 13 diamonds. And it's all written here for you. So we have 4 suits. Those are what the 4 suits are called. Then we have 13 types of cards, and I labeled them all above. So if we just want to take a single card out, we want the probability that it's a red. Well, half the cards are red. So exactly a half. If we want the probability of getting a face card and a heart, well, face cards are these, But if it has to be a face card and a heart, then the hearts is this row. So these are the only face card hearts, right? So that would just be 3 cases. And then out of a total of 52. If they wanted you to get a face card or a heart, then it would be like our union formula. So probably the first, which is face, plus the second, which is heart, and then minus anything we counted twice, which is a face and a heart. So face cards, well, there's 3, 6, 9, 12 face cards in a deck, okay? So 12 out of 52. Plus probability of hearts. Well, how many hearts are in the deck? Well, hearts are this whole row. So there's 13 of each, right? 13 hearts, 13 diamonds, 13 clubs, 13 spades. So there's 13 hearts out of 52. And then we just did this in part B, right? Minus 3 that are both face and hearts. So we'd have 12 and 13. So 25 minus 3, so 22 out of 52. Or divide by 2, 11 out of 26. So again, that's our OR formula or our union formula. Okay. Questions? Okay. So this one says if A and B are independent, okay, so think about what that means. Think about independent, where probability of A is 0.2, B is 0.5. Which of the following are correct? A and B is not 0. A union B is 0.6. Probability of not A and not B is 0.6. Only A and B or all of the above. So remember, if they're independent, then we know we can multiply, right? That's our formula since they're independent. So if we multiply probability of A is 0.2 by probability of B is 0.5, we get 0.1. So that's 0.1 and that's not 0, so that's true, right? So we can check mark A. It says A and B isn't 0, that's true, it's 0.1. Okay, well, go ahead and find your union formula and see if you can figure out B there. What would be your union? So go ahead and do it and see if you can finish the rest and circle the answer here. Okay, so probability of A, 0.2, plus probability of B, 0.5. minus A and B, I guess I just found, right? So 0.1. So that's 20 and 50, so 70 minus 0.1, so 0.60. So that is true. So the question is it D or E then, right? Well, if we think about a picture, these three places add up to 0.6. C is saying that the outside here is also 0.6. Could it be 0.6 as well, guys? What do you think? Does that make sense? It can't, right? Because if the whole picture has to add up to 1, then 1 minus 0.6 only leaves 0.4 for out there. So that cannot be true, right? So our answer has to be D, right? Because D says only A and B. Okay. Hey, questions? Next one. So, for example 8, determine if each set of events, F or G, are disjoint or independent. Explain what. Okay, so a coin is flipped twice. Let F be the event the first flip is tails, and G be the event the second flip is heads. Well, if we flip a coin twice, does our first flip affect our second flip? No. Does our second affect our first? No, right? That's independence, okay? The first flip won't affect the second, right? They don't affect each other. So what you get second is not dependent on what you just got. The card is dealt from a deck of cards. Let F be the event the card is a spade. Let G be the event the card is an ace. So getting a spade and getting an ace. Well, here they talk about one that is a suit, right? F is a spade, that's a suit. And then they talk about G, which is the denomination or the number on the card. So as long as they're talking about one that's a suit and one that's a number on the card, or it also could be a spade and not an ace, or it could be not a spade and an ace, right? So the not can be in there as well. But as long as one is a suit and one is the number on the card, then that is going to be independent as well. Okay, so one is a type of suit and one is a denomination. And the last one here, a card is dealt here, and it says, let F be a card as a spade, and let G be the event that the card is a heart. Well, in that case, these are both suits, right? So that is not independence. That would be disjoint or mutually exclusive, okay? Because we cannot get a card, right? A single card can't be both a spade and a heart, right? So this is disjoint or mutually exclusive. Another example could be, let F be the event that you get a king, and let E be the event that you get a queen, right? We can't get a card that's both, so that would also be disjoint or mutually exclusive. Okay, any questions? Okay. So Connor draws 3 cards with replacement. So remember that means puts them back in each time. And it says, find the probability that he gets 3 diamonds. Repeat if we don't replace cards. And then find the probability he gets at least 1 club. All right, take a minute. Let's see what you can come up with here. Okay, so in our deck, we have 52 cards and we have 13 diamonds, right? And 52 cards. So the probability that he gets 3 diamonds is that he gets a diamond the first time and is always multiplied. He gets a diamond the second time and he gets a diamond the third time. Now, because you don't have a calculator, you'll want to reduce that, right? A quarter of your cards each time is what you've got. So that would be 1 over 4 times 4 is 16 times 4 is 64. So when to use A given B, we haven't done that yet. So we haven't talked about conditional. So that's when you know something has already occurred, which we aren't even close to doing yet, but I'll tell you when we get there. A union B is when they ask you about being an A or B or both, right? Or they can use the symbol. Remember, we talked about how you can modify those formulas for mutually exclusive and independent back on 118, right? So, if they ask you for a union and it's mutually exclusive, then the last term is 0, right? Okay, so if there's no replacement, what's the difference in your answer? Well, you would still start out with 13 over 52, but then what's your next fraction going to be? What's your next fraction going to be? If you didn't put the card back in, now what's the probability of getting another diamond? Well, if I didn't put it back, there's now only 12 left, and there's still only 51 cards. So then if you didn't put it back in again, now there's 11 left out of 50 cards. Okay. So to add to my answer, Renee, also, it doesn't have anything to do with mutually exclusive because they could ask you for A given B when they're mutually exclusive or A given B when they're independent or A given B just in general. So yeah, all 3 are possible. Same with the union, right? We've done the union when it was mutually exclusive and independent and then just in general when we have to find A and B. Okay, so at least one club means 1, 2, up to, we're taking 3 cards out. So I guess it's just 1, 2, 3 clubs. Okay, that's 3 different cases. So, you could do getting 1 club or 2 or 3 and add them up. But you could also just do the missing case and subtract from 1, which is a lot faster. So anytime you want at least one, I would always just do 1 minus the probability of none. So, well, can you think about what that would look like? If you had no clubs, you didn't want to get any clubs, think about what you would be multiplying here. No clubs. So getting a club is the same as getting a diamond, right? 1/4. So, probability of getting a club is 1/4 of the cards are clubs. And so if we want not to be a club, then it's 3/4 of the cards. Okay. And this, I guess I should write with replacement since I changed it in B, but, I guess it says it up in the question, so it doesn't matter. Okay. Okay, so 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So we'd have 64 over 64 minus 27 over 64. So 37 over 64. Okay, so number 10, let A and B be two events to find on a sample space with probability of A 0.4, probability of B 0.5. It is known that the probability of A or B is 0.8. Which of the following are true? Okay, or is another way to say the union. All right, let's see what you can come up with. We've done lots of these, so I'm hoping you can come up with something to decide whether they're mutually exclusive or whether they're independent or neither. Think about the formulas that you know here, okay? Okay, so what I would look at is my union formula. Probably the first plus the second minus first and second. So this is 0.8. That's going over on the left. Probability of A is 0.4 plus B is 0.5 minus the and. So now I can solve, right? 0.4 and 0.5 is 0.9. So 0.9 minus what is 0.8? Well, that's got to be 0.1. So that's not 0. So are they mutually exclusive then? No, right? It would have to be 0 if they were mutually exclusive. So therefore, they're not mutually exclusive. Okay, think about how do you check independence? To check independence, we said we're going to check if, so are A and B independent? then we would know that A and B would be A times B if they were independent. So if you check that and A and B is A times B, then they're independent. If it's not the same on both sides, then they're not. So A and B was 0.1, A times B, A is 0.4, B is 0.5. So that's going to be 0.2. So they're not equal, and so therefore no, right? So they're not independent and they're not mutually exclusive, which means they're neither. But remember, most examples are neither, right? You just can't have both. You can have one or the other or neither. Okay, you're doing awesome. So go take a break and come back at 1:15. We're almost done what we call basic probability, and then we just have one more section on conditional, okay? So hang in there, go take a break. I'll see you soon. Hello, everyone. Welcome back. I hope you had a good break. So, final stretch, you can do it. So, post any questions on the Q&A, of course. And, the video will be up from yesterday's session sometime later today. And today's will be up sometime later tomorrow. And, of course, you can tell your friends if they couldn't make it to just sign up and watch the videos, okay? And they'll still have access to everything that way. Okay, so we are on 125. So Ashley, it's because of you're thinking, I know, the word or for English, but we're using the or as in math here. So A or B includes A or B or both. Now, having said that, there have been times, not in this course, but in another second year course where students argued it because they took it as one way and it was the other. And they did, in this particular course, give it to both, like the students for both ways, where they did it the math or versus the English or. Hopefully it won't come up on the exam, but if you're unsure, I would always say ask, right? If you're unsure of the interpretation, okay? Yeah. Okay. So for this one, we've got E and F are mutually exclusive. E is probably 0.3, F is 0.4, and we want to find all of these things. Okay, I'm hoping this is easy now. Think about mutually exclusive and write down what you think for each of those three. Okay, so remember, if we have mutually exclusive or disjoint events, our picture looks like two separate circles, right? So if there's E, then there's F, which means everything that's not in E or in F out here would be 1 minus these. So 4, 5, 6, 7, so that'd be 0.3. But for example, if we wanted the union, well, it's normally E plus F minus the middle, but there is no middle. So the union just becomes E plus F, right? So we talked about that back, I think, maybe 6, 7 pages ago. So it'd be 0.3 plus 0.4. If we want not E and not F, well, that's kind of what I just did here, right? So this is not E and not F. So that's 0.3. And then the tricky one is this one. Because, normally we have this overlap, right? So normally if they cross over each other, and this is E and this is F, then this would be what's in E and not F, right? But guess what? In E and not F here, every part of E is outside of F, right? So to be in E and not in F, to be in E and not in F, all of E is outside of F. So it's just the probability of E. The whole circle of E is in E and not in F. Okay, so that's a bit tricky. So this one, Something similar to this was asked on an exam. It's a pretty straightforward one. You know, if you've got 80 kids, 50 play on the swings, 60 play on the slides, and 40 play on both, what's the probability they play on swings or slides? So in this case, or remember, is your union, right? So if we do swing or slide, that's just your union formula. Now you're given numbers, but of course you know how to calculate probability. We've done tons of them, right? So how many people out of the total, right? Just like how many numbers on the die we have out of 6 total. So write down your answer here. What would it be? Okay, so we do the probability of the first one, which is swing, plus the probability of slide minus both. So the probability of being on the swing is 50 on the swings out of 80 kids, plus 60 on the slides out of 80 kids, minus 40 out of 80 both. Okay, so I'll let you finish that one later. And of course you can find the outside, you can draw then, or just think about the formula. Okay, so you can always use that the probability of being on neither is 1 minus the union. Okay, so that's a formula that will always work if you don't want to draw the then. Okay. Okay. So I want to do 14 and 15 here. So 14, I just want to show you this because that's, you know, one of those formulas I was talking to you about, right? So I know we've done lots of Venn diagrams. So you have A, you have B, you have the outside. Easy to find the and, just use your union formula, but I just want to make sure you know this. So here, if we have a union and we've complemented the whole bracket here, remember that means we complement both sets in the bracket, and A is already complemented, so we're complementing the complement. And then remember what we do? We complement both and then we switch the sign. So this would be A complement complement just actually takes us back to A. So once you do your part A, use your union formula, you can just, you know, draw it out and think about this is not in B and in A. So really they want this, right? In A and not B. Doesn't matter the order, not in B and A is still, you know, in A and not in B. So all you'll do is take whatever the total of A is and take away the middle that you just found in part A. Okay? So I'll let you try those later. All right, so now we're going to do a hard one, and then we're going to do conditional, our last section. So for 15, for the next one here, it's giving you a bunch of numbers in sets and then asking you for a whole bunch of different probabilities, okay? So A is 1 to 6, B is 2, 4, 6, 8, U is 1 to 8, the whole universe. so the total sample space. And we want to know, what is the probability of our being in A complement union B? So A complement union B. Okay, so we can do this in different ways. So let me show you some options. First option, we could say if A is 1 to 6 and the whole universe, the whole picture adds up to, has 1 to 8 in it, then if that's A up to 6, then we could say that not A is 7 and 8, for instance. And then we know B is 2, 4, 6, 8. So if we want the or, well, remember the or is in one or the other or both, right? So this means we could say in A complement or in B. Or you can say not in A or both. So that means we just write it down. So the set of A complement union B would be everything in this and everything in this, but we don't write anything twice. So we'd have 2, 4, 6, 7, 8, right? That's the union in one or the other or both. So then we could say, well, the probability of that being an A complement or B or both is how many things out of what's our total. Our total is 8 numbers. And so that is 1, 2, 3, 4, 5 numbers out of a total of 8. So that's the total in your full sample space or your universe. And this is the number in this set, right? Which is here. So 5/8 would be our answer. But we could also use the union formula. So we could also say probability of A complement plus probability of B minus A complement and B. So there's always going to be options in these styles of questions. A complement would be 2 numbers out of 8, plus B would be 4 numbers out of 8. And in A complement and in B, what's in both of these? A complement and B is, it's like just the number 8, right? So that would be 1 out of 8 in common. So it's seeing the answer, it's just a different way to look at it. So you've got to pick which one makes more sense for you, right? Because they're both right. Questions? So this one's an and, right? So that means it has to be in A and in B complement.